Okay, I feel like we can start now. So if you somehow don't know, we're gonna take a look at the animation process from the previous devlog, and I've prepared a small Unity project here to kind of show you that. So I don't want to use my main Astortion project to not spoil you some things that I'm working on. We have a very simple setup here. We have the sprite renderer with a reanimator that plays a really simple walking animation. And the walking animation as of right now is just a simple, PNG animation. There's nothing special going on here. When it comes to the code, we have 3 different classes here, and the source code for that is in the description. You can get it from my gist, GitHub. We're gonna take a look at them when the time comes and what they exactly do. Yeah, and other than that, I also configured the Unity texture importer to immediately upon importing something, set up the pixels per unit and no compression, no filtering. So I'm not gonna do that during this live stream because it's automatic. But usually you need to do that, right? All right, so let's start with taking a look at the texture post-processor. And here's a small correction to my previous devlog, because I called this texture, I called it asset importer, when in reality it's called an asset post-processor. And what it does, it allows us to transform the assets that are being imported to Unity in different ways, however we want actually. It has these event functions. In this case, we're using the onPostProcess texture event, and it gives us an access to the texture that has been imported to Unity. And as you can see, what we do here, we essentially check if the extension of this file is PNG, and if it's not PNG, we're not interested in it. And then we handle 2 different types of files. First, we have the pixel map, which is the map from the video that tells us where specific colors, how to translate them to UV coordinates. And it has to end with a prefix .map. The other types of files are I'm calling them weights in the code, but I later changed that to source. And this is the source animation from the video. So the animation that has the colors overlaid on top of it. And we essentially import them into different ways. So I'm gonna go to Asprite. And I have this map prepared here. This is the map from the video. And I'm gonna basically save it in my project. This is the assets folder in Unity. And I'm gonna save it in sprites skins as a map. And as you can see, the extension is .map. So it's alice.map.png. And when I save it and go back to Unity, I loaded it here. This is the map. And as you can see, the script generated a separate scriptable object that contains the lookup information from this map. So going back to the code, if you take a look at this function, which is invoked upon importing a map, what it does, it first tries to find a map that already exists for this texture. And it does that based on the name. So it's gonna essentially, if the file is named alice.map, it's gonna search for a texture that's a scriptable object that's called alice.map. If it doesn't find it, it's gonna create a new one. And then what it does, it essentially reads the pixels from the texture, clears the previous lookup data, and fills it with information about our lookup. It iterates over, because this is like a one-dimensional array of pixels, and we then change this to UV coordinates by essentially first taking the module of the width and then the division. and then we save the scriptable object. And so what we end up with is essentially this scriptable object that has the color and the UV coordinates of this color on the map. When it comes to the scriptable object itself, it's defined here in this pixel map file, and it's essentially just one object with a serialized dictionary which maps colors to vectors. And that's pretty much it. And a serialized dictionary is, I'm pretty sure if you've been using Unity for some time, you probably have an implementation of it somewhere. It essentially allows you to serialize dictionaries, because normally you cannot do that. So the way my implementation works is that there is this struct that holds key and value, and it's serializable. And I have a list of these pairs. And then, before serializing unfill, I fill this list of entries, and after deserialization, I enter these entries back to my dictionary. So that's pretty much it when it comes to the map. And once this asset is generated, we can use it to import other animations that will have these colors turned into UV coordinates. So if I open again this folder with my walk animation, what I need to do is I need to save this using the prefix that we expect here. So in this case, we expect the file to start with source dot. So if I'm gonna go back to Asprite and save, this is, by the way, this is this walking animation, open Asprite, and I'm gonna save it as in the same folder as source.alice_walk. I'm gonna go back to the naming convention in just a second. Now when I save it, go back to Unity, it's gonna be imported. And now we have our source animation, and you can see that you can actually see that in the viewport that our walking animation now doesn't work. And this is because Asset Importer tried to convert this source animation to UV coordinates, but because the source animation still uses normal colors, it cannot find it. It cannot find them on the lookup in the lookup data. And actually, the only color that it could find is this leg, which I believe is white. This is why, because white is also, this white is also here on the map. So it was able to find only this one color. And now, once we have something like that, out of curiosity, do you plan to release your video animation software? Yes, I do, actually. I'm not sure. I was hoping it's gonna be ready with the release of my next video, but now I see that it's not gonna happen. But in like a month or maybe two, I do plan to release it. I need to learn to look at the chat, by the way, so everything is new to me. Okay, going back to the animation. Now we need to overlay the colors, and the way I do that, essentially, is I simply copy this map, create a new layer, temporarily extend this canvas, and just paste it here to have it there, right? And then I make it so that it's linked and not editable. And now if I create a new layer, I can simply sample the colors from there and paint them over the animation. Another thing that you could do technically with Asprite is create a palette for this specific map, right? And if you adjust the width accordingly, you'll end up with something that looks exactly like this. And now you can use these colors if you prefer. But actually, it takes a lot of time to set this up, and I prefer this this solution. Yeah, now there's pretty much nothing more to it. You just need to go over this animation and apply this these colors. And I like to start with the left leg because it's the most complex one. And the way I think about this, you can see that these are 4 different stripes. For me, this is the front of the leg, this is the left side, this is the back side, and this is the right side. So if you were to take a look at this from top, it would be something like this, right? So at any point you can see like up to 3 different sides of the leg. So this stripe here would be what is the most on edge on this leg. And I'd essentially start from, usually from the middle, because this violet stripe, as I said in the video, represents the knee. So I'd basically, you know, figure out where the knee is, place it here, and then essentially go through the entire animation and try to place it where it belongs. Right, and this is pretty much it. And now that I have this reference point that is the knee, I can, you know, go up above the knee and place what I think would be above it. This would actually be probably somewhere here. Right, and this is essentially how the process looks like. As I said in the pinned comment under the video, it takes me around 30 minutes to do like one animation like this. And then obviously other parts of the body are a bit easier. Head actually doesn't change that much throughout the entire animation. So I can just copy this. Or can I? I think I need to select this layer actually. Yeah, I can just copy this, remove what I don't need, and just overlay it. Right, and this is pretty much it. So I'm not gonna go through the entire thing here, because I don't feel like there's a reason for that. Instead, I have the animation prepared here. That's already finished. So I simply, I'm going to copy this entire layer and just paste it here. And go back to this smaller canvas. So now when I save this and go back to Unity, as you can see, now we actually do see the silhouette of our character. And the asset importer, the asset post processor took care of that. And the only thing that's left to do is the only, excuse me, the only thing left to do is to create a shader that's gonna, you know, display the map. But before we do, I'd like to address some ideas that people had under the previous devlog. So for instance, one of them is to use palettes to do this entire thing. And so my main problem is, even though you could do that, it's like I'm gonna show you what I mean by that. When I create a new sprite in Asprite, I can choose indexed as my color mode, right? And this essentially allows me to refer to colors not as RGB values, but as IDs that refer to this palette here. And then I can change the palette and it's gonna automatically change the colors. So technically I could load my palette here, right? And then paint with this. And then all I'd have to do is to change this palette to something else. But the problem with Asprite in general is that if I the process seems really long, especially with the number of animation you have. Isn't there any way to optimize the redraw of your animations? There may be. I'm not saying that there's, I just haven't figured this out yet. Somebody proposed, for instance, rendering a 3D model and then just cleaning it up. So, you know, removing every pixel that's like unnecessary and so on. Maybe that would be faster. But yeah, definitely, you know, there's much more room to improvement. I don't find it that tedious, but then again, my sprites are like 24 times 24. So it's not that big of a problem. Going back to A-Sprite, when I pick this color from the leg, for instance, and try to draw with it, I'm actually painting with transparency. And the reason for that is that A-Sprite supports only up to 256 colors in a palette. And 24 times 24 is a bit more than 256, so that's not gonna work. But if your sprites are like 16 times 16 pixels, or your map actually, if you could like fit this map, which I think I could if I tried, then you can use that, and that may be a little bit easier to work with. Now going back to Unity, if I could find it here. I'm gonna create the shader for this using the shader graph. Because I assume if you know how to create shaders, you know, with code, then you'll be able to simply translate it. And I'm pretty sure if you can, you probably figured out how to do that already. Shader graph. And what I'm looking for is spritelet shader. I'm gonna call it skin shader. And immediately I'm gonna create a material for it. And apply it to the player. Okay, so as you can see, it doesn't work. And now we can set up this whole shader. So first of all, I'm gonna add the main texture here so that we can actually display it. If we create a variable, right, with reference set to underscore main texture, it's gonna take the texture that's assigned to the sprite renderer and allow us to access it. So I'm gonna just sample it. Hi, hello. And simply display the color for now. I'm gonna maybe display the game view here. Let's make some more space for it. So I'm not sure if you can tell on the stream, but we can see the colors here, and I can use the alpha value to get the silhouette. And we're essentially where we started, right? This is like the most basic shader that you can have. So now what we need to do is, instead of using these values to, you know, create color, we want to use them to sample another texture. So first I'm gonna create a reference to another texture. I'm gonna call it skin texture. And before we proceed, I'm gonna quickly pick this material here, and I'm gonna assign the texture that we've prepared. So this is the default texture. Okay, with that set up, we can use this skin texture and sample it instead. So now the problem is that these values here, they're gonna range from 0 to 1. These are gonna be floats. It's not from 0 to 255, but 0 to 1. They are normalized, in other words. So first thing that we need to do, I'm gonna combine them into like a two-dimensional array. First thing, we need to multiply them by 255 to go back from this normalized range to our range that we are used to. And then another thing that we need to do is use the texture size, which we can access from our skin texture using a node that's called texel size. This will essentially return to us the width and height of this texture. I'm gonna turn this into an array as well. Right, so the way it works is that on this output, when there's 0, we mean like maximum to the left, for instance. When there is 24, we mean maximum to the right. And this is 24 essentially because this texture size has 24 pixels of width. But for UV sampling, we need to turn them again to normalized range. And to do that, all we need to do is divide it by this. And now if everything is correct, which I hope it is, you can see that nothing works. We are sampling colors, but something is a little bit wrong. And the reason for that is that after we multiply these values times 25 times 255, we end up on the edge of pixels. We are between, essentially when we have a value of 23, for instance, we are between the 23rd and the 24th pixel, and it results in a very random behavior. So to offset that, all we need to do is add 0.5 to this thing. So this way we're gonna move it to the center of a pixel. And now, as you can see, the sprite is looking normally again. And just to prove kind of that it works, I'm gonna go ahead and modify this texture, right? If I add something on it, Unity is gonna reload this texture, and here we are. So another thing that people talked about was exporting these UV coordinates immediately from Asprite or from any like pixel art software. And you can do that. You could write probably like an exporter, but what I like about texture post-processor in Unity is that you could, for instance, say that I'm gonna move this, I wanna rearrange this map, right? So I'm gonna move it here. And now it stopped working. The leg is not being properly rendered because there's a mismatch between our UV coordinates and our actual map. And with a texture post-processor, all I need to do is edit the map as well. In the same way I edited the skin texture, I just need to edit this. And Unity will regenerate this lookup texture. So all I need to do is re-import these. And as you can see, it's fixed. Depending on the software that you're using, you'd need to re-export every single animation to readjust the UV coordinates, which may or may not be a problem. But this is just like one thing that I like about texture post-processor. I'm gonna fix it back so that it's not broken. Oh, and like I knew that when I'm gonna say that it's not gonna work, I need to re-import the map again because for some reason Unity did not pick that up. Yeah, but this in general is the entire process. I'm not sure if you have any questions. I feel like a teacher on like remote working, remote lessons. No, I don't see any questions, so I'm assuming that everything is clear. Again, the sources are in the description if you'd like to, play around with it. That being said, I'm not... What's the future plan for this? For what? You need to be more explicit. I don't think it's maybe he means if it will become a tool. I don't feel like it deserves to be a tool. It's too simple, in my opinion. Like, you've seen the code for this, right? It's essentially 3 classes with like 100 lines of code. I was thinking about adding this to this whole UV wrapping of 2D sprites. Okay. Yeah, I was thinking about adding this to my pixel graphics package, but then I opened the pixel graphics package and it turns out it's not that easy to update a package when Unity changes versions, because they've changed so many things in the universal render pipeline that I was like, no, I don't feel like fixing it right now. But maybe when I go back to it, I'm gonna add it there. I personally don't have any plans for turning this into like a full-blown tool. Maybe in the future, because there's a lot of things that I want to do with it, right? This is just the beginning. A lot of people mentioned that already in the comments. For instance, the lighting, depth, etc. Because notice that currently this leg is darker than this one, right? This is the foreground leg and this is the background leg. This information about what is behind the character and what is in front of it can be also encoded using like a different layer or a different channel, maybe that's how I should say that. So there's gonna be more videos about this. Another thing that I didn't have the time in the previous devlog to tell you about, but I'm also working at the ability to display certain things near the player's head. So if I wanna, display like a little emoticon that's gonna follow the head, okay, I also want to be able to track this the position of the head and the orientation. And this is also gonna be done in a similar way. So there's a lot of things, a lot of plans that I have for this, and this is like, I really like this idea, so I wanted to make the devlog as fast as possible. But there's gonna be a follow-up to that at some point. Yeah, but if there's no more questions or anything like that, there is gonna be, I'm gonna actually edit this stream, create like a little highlight video and upload it on this channel, with all the pauses and awkward breaks cut out so that people can watch it easier, right? Because there's no point somebody would have to spend half an hour watching this if this can be provided in like 10 minutes. And from when it comes to other organizational matters, I'm thinking about making streams like that after every devlog. I'm not sure if it's a good idea. So, if I release the devlog, can you make a tutorial about the Unity scriptable render pipeline? No, because I have no idea how it works. I wish I could. Like, I'm not the competent person when it comes to the universal render pipeline. Essentially, especially since, the last time I did something with it was like 6 months ago. And, now I'm back to it and there are so many different things that has changed. But yeah, I'm pretty sure there are like very good, tutorials out there on YouTube. Understandable. Yeah, but as I was saying, I'd like to make these streams periodically so that, I release a devlog on, say, Thursday, and then the next Saturday we're gonna have a stream like that, because I always think that, I've prepared myself with the script in a way that, leaves no room for questions, and then there's so many questions that I wouldn't have even thought about. So I feel like we could benefit from a stream like that. I'd simply, gather all the questions from the devlog and then go over them on a live stream on this second channel. So if you're interested in something like that, you can subscribe to this channel to, get notifications about that. Sounds good. I'm glad to hear that. Yes, that would be nice. Okay, so I'm certain now we're gonna do it. Hi. I'm not sure if you're saying hi as in goodbye or hi as in welcome. If you're saying hi as in welcome, then we're essentially ending the stream. So we've went through the entire thing. So actually, I'm actually surprised how fast it was. I was preparing myself for like an hour-long stream. Apparently, there's not that much to it as I thought. I mean, again, it's not that complicated, right? Yeah. Well then, bye. Okay, so I feel like there's nothing more to add to that. Thank you all so much for participating in the stream. It was amazing. And I'll probably see you at some point in the future. Bye bye.